The hypergeometrical universe theory. The theory of everything. Adiabatic cooling in space according to Dr. Marco Pereira. Is there adiabatic cooling in space as some scientists might want you to believe? Of course not. Is there adiabatic cooling in space? We all hear that the universe was hot, and later, it cooled because of expansion. That is called adiabatic cooling. The reasoning behind it is that the universe is a closed system. It is not, but there isn't anything outside to exchange energy with. For adiabatic cooling to take place, there should be thermal equilibrium. We know that atoms are very far away from each other in space, and they might have very low temperatures, low velocity. You can calculate the time between collisions, which can be millions of years. In other words, the universe doesn't allow for thermal equilibrium. The hypergeometrical universe theory, HU, provides a simpler solution to this problem, the same one it uses to explain why galaxies are like dots on an expanding balloon. This is the inertial motion of atoms that will eventually form galaxies. Notice that before galaxies are formed, the gas temperature has to cool down. This means that if you can explain the cooling, you can explain galaxy formation. The straight line in a 4D spatial manifold represents the inertial motion of a hot hydrogen gas. The absolute velocity decreases with motion, as can be seen by examining the angle between the trajectory and the radial direction. This explains why gases cool down as the universe expands. It has nothing to do with the stretching of space. Once the gases coalesced on their Hubble points, galaxies could form. So, this explains why galaxies, all of them, are like dots on an expanding balloon. So, scientists who know less than I know will say words like adiabatic expansion and Charlie's law. But that is wrong. By the way, I used this model to find the time when galaxies started forming after the surface of last scattering, the one that originates the cosmic microwave background. It is often stated that gases in space cool due to adiabatic expansion, with Charles's law frequently cited as an explanation. This analogy typically references the cooling effect observed when compressed gas is released from a container, as seen in an aerosol can. However, this explanation is incorrect in the context of astrophysics. Charles's law, temperature is proportional to the container volume, assumes a gas expanding within a confining container at constant pressure. In space, however, there is no container, gas expands freely into vacuum. No external pressure opposes expansion, so traditional thermodynamic work, PDV, is not well defined. Adiabatic expansion assumes a closed system, whereas gas in space can interact gravitationally and kinetically with other particles. A more appropriate framework for understanding cooling in space involves dynamics rather than thermodynamics. Whose solution? Kinematic cooling via inertial motion in 4D. The hypergeometrical universe theory provides a new explanation for gas cooling in space, one based on kinematics instead of thermodynamics. In HU, particles follow straight-line geodesics in a 4D spatial manifold. As particles move, the angle of their trajectory with respect to the radial direction decreases, see diagram above. This results in a natural reduction of absolute velocity, leading to an effective cooling mechanism. Thus, gas cools because of inertial motion and velocity reduction, not due to adiabatic expansion. All atoms undergoing this process eventually coalesce on the Hubble point within the hypersphere. Hubble point is the point where only the radial motion is enough for the body to be receding from you at its observed receding speed. This mechanism does not require a thermodynamic interpretation. It emerges purely from the geometry of motion in 4D space. Always feel free to ask any questions. Please share my work in your profile and in your groups. Every second counts.